Welcome to SIM-PAC Live. I'm your host, Geoff Matthews, and today I'm with Glenn Morelli, the founder of Tindo Solar. We're in his factory here in South Australia, and he's going to take us for a look around. Welcome, Glenn.
Yeah, thanks, Geoff. It's great to be here and great to welcome you to Tindo.
Yeah, let's go and have a look at this factory.
Let's do it.
So here we are at the very start of the line. What we have here is a laser cell cutter. So we're inputting a full cell. We're actually going through a bit of AI there. The blue light is actually imaging every cell. If the cell integrity is not right, it will put it to a side and won't use it. And then on the right there, we're laser cutting each cell in half. And so we're using a half cell technology in our solar modules.
And these cells are so small, doing this by manual.
Impossible.
It's impossible.
They're 120 microns,
Yeah.
so that's 120,000th of a millimetre thick. Very fragile. Everything we do in the factory here is about protecting those cells.
Yeah.
They're the engine room of the panel.
Right.
Then we get the half-cut cell. We put them into the stringer machine. So we have the wires here, which are about 2.5 times the thickness of human hair, that are going to join those cells together to start formulating the circuit of a panel. We come down this way. You can see we get the wires. The cells come along the back. Underneath that robotic arm there, we're actually imaging the cell again. We're now imaging the half-cut cell. Any cells that don't pass that test go into that tray at the front. The red light there is we're preheating the cell so we don't stress it when we solder it. So we're warming the cell up. We're getting the wires, we're cutting them to the right length, and then we're interlacing them under and over the cells.
And the heating's been done by infrared or something?
Yes, it is.
Yeah.
And then we put a jig on top. Once the wires are in place, we put a jig on top to hold the wires in exactly the right place. We're talking again, thousandth of a millimetre of accuracy.
Yeah.
And then we come down here, and they're being laser soldered at this point. So nothing touches the cells as such. Laser soldered, and then take the jig off, and we've got 9 half-cut cells now all joined together, start forming some short strings.
Wow.
Then we get that string, and we're putting a charge through that, or a current through that right there. We're doing an electroluminescence test. So we're looking for any resistance within that string, and we're going to take that out if we find a problem with it.
Yeah.
So that the process for us of making a high quality panel is a process of elimination. So we're taking out, we've got AI and QA along all the line, and we're taking out the bits that don't quite meet our standard.
Yes.
And so by the end of the line, we've got a perfect module every time.
Yes. And that's why you've got a 25-year guarantee.
100%.
And you find your performance out in the wild, in the real world, is superior to, say, other imported products?
Yeah, so we've got product at Desert Knowledge Australia. You can log on to Desert Knowledge, which is a government-funded test facility in Alice Springs. There's about 45 different modules there, or arrays from different manufacturers.
Yeah.
Ours outperform every other array there any day of the week.
Yeah.
So proof's in the pudding.
Yeah. Made here in South Australia.
Yeah. So let's go this way. Geoff, there's the result of the electroluminescence test. So that's on that short string where we put a current through. So the software is automatically highlighting where there might be areas of concern.
Yeah.
And they will go offline. We will check them later. We might cut out a cell or reprocess that string before we would even look at using it.
Yeah.
At this here, this is a string layer. So we've got a sheet of glass, a layer of the PoE, and then we're laying those short strings onto it to start formulating or forming the panel as such.
Right.
Yeah. Once that's all done, which is just about, 2 more strings to go on there, we come around here. And this is our auto solderer. So we have over here the buzz bar. So that's the buzz bar that goes in the top, middle, and bottom of the panel and closes the circuit.
Yeah.
In a panel this size, this is a 430 watt residential size module, there's about 1,300 solder joints.
Wow.
And between the stringer and this machine, we're doing those 1,300 solder joints in about 60 seconds. So you'll see here, we lift up the cells. It'll rejiggle now to make sure it's positioned exactly right. Again, accuracy. Buzz bar comes across and now we're soldering. Drop those cells back onto the glass and then that module comes through. So as we can see, all the circuit is now closed. So effectively that's one circuit now. So we've got the real formation of a panel.
Yeah.
Morning. Good. So at this point here, this is now the first time we actually have got any human intervention into the process here. So if you think about these buzz bars that just got soldered on, they've got to carry 1,000 watts, 1,000 volts over 30 years.
Yeah.
So it's really important that they're done properly.
Yeah.
And so we've injected a manual QA check at this point.
Yeah.
Because over the years of manufacturing since 2010, we've come to realise that this is a failure point of a module.
Yeah.
And so we do a double check, and as we can see here. At this point also, each module gets its own serial number, and the module is tracked from this point on by serial number.
Right. And what is it like the failure rate at this juncture here?
With the testing we've already done, 0 at this point here.
Yeah.
We'll do a couple more tests before we go to lamination.
Yeah.
And we may take some modules offline then and rework them.
Yeah.
But at this point, this is just a QA check, and then do what we've got to do and push it through.
Easy.
So this machine, Geoff, I affectionately call Australia's most expensive sticky tape dispenser. All we're doing here is putting a little bit of tape between the cells, and that's to hold the cells in place ready for lamination.
Right.
When they get laminated, the POEs go quite gooey, and the cells can float a bit.
Yeah.
So this maintains the cell gap and the integrity and the shape of the module. We then pull over another layer of the POE.
Yeah.
And then the layer of the back sheet. So here comes the back sheet now off the roll. It gets cut to size. There. Module comes through. And then perfectly lines up. And dropped on.
And the equipment, the robotics, how much of this is off the shelf you just purchased, or is any of it, bespoke for Tindo, or
So when we went through the process of designing the factory, our engineers, who've been our chief engineer, who's been manufacturing solar panels now for nearly 20 years.
Yeah.
He knew who the good manufacturers were and where the good equipment was. And so he cherry-picked the market, sourced different machines from different manufacturers, and then we integrated it ourselves here.
Wow.
Yeah.
And with that integration, any time somebody uses the word integration and technology, it sounds painful.
Yep, very. So now you see, Geoff, we've got all the layers of the module. We've got the glass, the first layer of the POE, the cells, the second layer of POE, and then the back sheet.
Right.
That's now all the layers ready for lamination. We do some more QA at this point. Now this is a really critical step of the quality process. So if you think back, the start of the line, we imaged the full cell.
Yeah.
We took out cells that didn't meet requirements.
Yes.
We then imaged the half cell. We took out cells that didn't meet requirements. We then did an electroluminescence test on the short string,
Yeah.
and we took ones out that didn't meet.
Yeah.
Now we're doing an electroluminescence test on the whole module.
Yeah.
All right? And so here we have a module in there. This is what I call the X-ray of a solar panel.
Yeah.
We're looking for any defective cells. We're looking for micro-cracking. We're looking for any resistance within the strings.
Yeah.
As you can see here in the image here, it's defect-free, which is often the case when it gets to this point. But if there was a defect, we take that module offline, we will cut out the affected cells, resolder in new, and then retest. What we're doing is absolutely minimizing waste.
Yeah.
Because if we were to laminate a module, not do this test, laminate a module that had a defect in it,
Yes.
when we get to the end and we do our final test and it doesn't meet spec, we've wasted all of those materials.
Yes.
All right? So we're very sustainable in the way that we manufacture the modules as well.
Yeah.
So from this point, it passes and goes through to lamination. Not a lot to see in here, but big laminators, just like office laminators, 150 degrees Celsius for 20 minutes.
Yeah.
And that's for the 2 layers of the POE, for the molecules of those that bond together.
Yeah.
And that will make the cells, no moisture, anything will get to those cells, so they will last for 30 years.
Yeah.
Along with the heat, we have vacuum and pressure.
Yeah.
So as I said, just like a big office laminator.
Yeah.
So here's one that's just come out of lamination. You can see it's all glued together now. There, nice and tight.
Yeah.
What we then do is trim off the excess overhang of the glass with our auto trimmer here.
Yeah.
This is the only waste product we get from manufacturing the solar module.
Right.
Is that little excess. We now do our first manual inspection post-lamination. So we're looking for any cell movement during the lamination process, any foreign matter that might have got caught in the lamination, such as a hair or a bug or something like that. And we're cleaning down the face of the module, making sure it's 100% perfect for presentation at the end.
Yeah.
We now have framing. So we have the cassette of frames at the back there. We're using a black frame. You can see that robotic head that's moving from left to right. That's actually silicon injecting the frame. It'll move again in a moment. Here we go. Those frames then get brought up to the front here. The module comes through and we hydraulically squeeze the frame onto the module.
You can hear the hydraulics working away there.
Yes.
And Glenn, you've recently made an announcement with doing a partnership with Capital Aluminium.
Yes.
I assume this is for the frame?
Yes, 100%. So here's our frame here. It's actually a Tindo proprietary design.
Yeah.
So the silicon is injected in this recess here, so we have no exposed silicon to UV, which so then it can't be affected by sun over time.
Yeah.
Our frames have these mechanical joins on the miters, and so they're very strong. And the other feature of our frame, it's a 35 mil. Most modules coming into Australia now are 20, 25 mil, and so we have a much greater rigidity of the module. And that protects the cells over time from micro-cracking, for high wind zones, cyclonic conditions, etc. The frame is a real critical part of the panel that a lot of people forget about.
Yes.
The reason that frames are getting thinner and thinner is for 2 reasons. One is cost.
Yes.
And 2 is so you can fit more in a shipping container from overseas.
Yeah.
So it's purely about a cost saving, but it's actually putting at risk the integrity of the module. And you're right, Capral, we've recently signed an agreement to onshore the supply chain for our frames and buying them from an Australian company, which is just great.
Yeah. And in terms of rigidity, you know, going from 20 mil to 35 mil in an L-shaped bend is, you know, it's probably triples or something. It's not a little bit, it's a lot.
No, it's huge.
Yes.
You can get imported modules with frames that are much thinner, and they're like a wobble board.
Yeah.
And every time there's any flex in that glass, you're actually potentially cracking the cells.
Yeah.
And micro cracking, which are cracks in the cell that you can't see with human eye.
If you're going to put that on a roof with wind and temperature change and everything else, the weather we get here, you need to have a solid frame for it.
All it does is any micro cracking will lead to premature failure of that module, lower yields, just not a good result for anybody.
Yeah, yeah.
Then we're doing the junction boxes, so they're robotically siliconed at the back. We fit them here. Again, we've injected this as a manual point so that we can control the quality. If you think about it, all the power of the module comes out of these junction boxes for the next 30 years, so they have to be done precisely and accurately and right. And so we make sure of that.
Awesome.
So that panel we saw just get the junction boxes soldered in, and it's coming now.
Yep.
What we're going to do here is pot those junction boxes. So we're going to fill them with silicon.
Yeah.
And so that'll make them impervious to any moisture for its life.
Yeah.
Again, over the years, we've established that the junction box is a failure point of the module.
Yeah.
And by doing this process, we never have any failures.
Yeah. Beautiful.
Then goes on to the curing line, and that's for the silicons in the frame and the junction boxes to cure off.
Yeah.
So one thing installers tell us about our modules is that they're always perfectly square.
Right.
And that's because once we put the frame on, we then let it cure, and there's no handling of the module, and so if the frames don't move that 1 millimeter, so they're no longer square. So if you're doing a large installation with a lot of modules in one string, you can look down and just see it's perfectly straight. Installers love that.
Yeah.
So this is just a little R&D area. So this is an electroluminescence machine from our old factory. So we use that for R&D. We've got a lot of laminates here that we just do different types and experiment with. We even have a water tank here. So we fill this with water and submerge panels in it and do testing.
Right.
And so we do all the R&D here, design everything.
Yeah.
To create the modules before we send them overseas for international certification.
Yeah.
Getting back to the panels getting made, they come off of the curing line and they come back around here. At this point here, we put the lids on the junction boxes, we fit it with a nameplate, gets a serial number on the frame, and then progresses to flash testing. So the flash tester emulates pure daylight, 1,000 watts per square meter, flash it on the cells, and then we record the electrical characteristics of it here. So you'll see this flash in a moment. There it is. And if we look up here, we're making a 430 watt module. That one was 434.924.
Right.
So we have a positive tolerance. So nothing that flashes less gets through.
Yeah. Brilliant.
The other thing that we do that, or don't do, that is done in overseas plants is we don't have a binning process. So we're only making one power class here at a time. So this is a 430 watt module.
Yeah.
Every module that gets through has to be positive tolerance to that. Otherwise, we do not sell it.
Yeah.
So what happens in other factories is they might be making a 430 as well,
Yeah.
but it might only flash at 420. Well, that'll go in a 420 pallet and they just relabel it. Or a 415 goes into a 415
Right.
pallet
Right.
and relabel it.
Or
And
or it goes into a 430 and gets shipped to some country like New Zealand or Australia.
But you as a consumer,
Yeah.
you buy from your installer a brand new 415 watt module,
Yeah.
and you think terrific. What you're actually getting is a 430 watt with some defect in it,
Yes.
unsuspecting.
Yes.
You don't get that with Tindo.
Yes.
After flashing, we file off the sharp edges on the miters.
Yeah.
That's for the protection of the installers.
Yeah. And Glenn,
We touch it back up with paint. Sorry, Geoff.
yeah, just a question about the volume of the factory. The factories here is because you've got plans for a new factory.
Yeah. So this is about a 160 megawatt facility.
Yeah.
So if we're running flat out, we can do about 1,100 modules a day.
Yeah.
We've announced plans earlier this year to scale to a giga facility, so a gigawatt facility.
Yeah.
Which, believe it or not, is somewhere in the vicinity of 7,000 to 9,000 panels a day.
Right.
So, and that's about 7 times the capacity of this factory.
Right.
So huge scale.
Yeah.
A gigawatt plus this creates about 20% of Australia's annual needs.
Yeah.
You'll see once we've touched up that module, we also put these corner blocks on each corner.
Yeah.
So this is a recycled material. It's our own design. They're manufactured here. What that does is no two panels will touch each other.
Yeah.
There's about a millimetre gap, and all the weight from the modules goes through these corner blocks
Yeah.
and not through the module or the glass itself or the frame.
Yeah.
All right. Great for logistics.
Again, so you're not stressing the module before it even
Correct.
put on the roof.
Now, I don't know of another panel that comes into Australia that has this type of thing on it. They're
Yes.
generally just in cardboard boxes.
Yeah.
And if we look here, this module that's right at the end of the process now.
And there she is, because we've been seeing the back for a while, and now we get to see. And it's interesting that the blue that you saw earlier is now sort of more black.
Correct. That's because we've got the back sheet on it, so you're not getting any light coming
Any light through. Okay.
So this is the final inspection now of the module, just making sure everything's perfect. You hit the button and it gets palletized.
Right.
Once it's palletized there, we come out into the warehouse. And here we go. So as I was talking about these corner blocks,
Yeah.
if we look at this pallet here, for example,
Yes.
you
Sorry,
cannot...
I'm taking in the scenery.
That's all right. You cannot move that. So for logistics, absolutely perfect.
Yes. Yes. And look, you talked about making the plastic things from recycled plastic. Did a lot of people going to ask about the recyclability of the whole unit?
Yeah. We get asked about that all the time.
Yeah.
Recyclers asking us, can we make panels that are easier to pull apart?
Yes.
Well, the fact is, if we did that, they probably wouldn't last.
They wouldn't last
30
yes.
years.
Yes.
So it's a bit of a difficult situation.
Yeah.
So there's two answers to that, I guess. Our theory is if we make a panel that's of high quality and lasts longer,
Yeah.
we're actually doing a good thing for the planet. We're
Yes.
getting, for the same invested carbon, we're getting more energy out and a greater return.
Yes.
And that's benefiting, against recycling because the panel lasts longer on a roof.
Efficiency is very much part of carbon emissions.
But in saying that, we also are working with a manufacturer that manufactures the encapsulants, the POEs.
Yep.
They believe they've got a technology that is a recyclable POE. So we're working with them towards potentially making the first proper recyclable panel
Yes.
available in Australia and possibly the world.
Yes, and of course the aluminium's always
100%.
infinitely recyclable.
Yeah.
So, good stuff.
So, which
And-
ones do you want, Geoff?
Yeah, I want a lot. So, and just philosophically, I'm fascinated by you, Glenn, in that you're the only Australian manufacturer of solar panels. And when everyone said, "Oh, we can never compete, we've got to go overseas," the journey to get here into this wonderful facility in this factory, which sounds like you're already outgrowing and planning a bigger one, that must have been some journey. That must have been, that required, staying in there and doing tough, did it?
Yeah, there's been some tricky times and sleepless nights at times.
Yeah.
But, it's just, I guess if you believe in something, you just keep pushing forward, ignore the detractors.
Yeah.
And, we're pretty smart here in Australia, and we're a pretty resilient mob.
Yeah.
And we just keep pushing forward.
Yeah.
I guess in regards to competing, everyone, makes the natural assumption that a Tindo panel costs a little bit more because it's made in Australia and there's Australian labour.
Yeah.
But as you saw in there, Geoff,
Yes.
there's very little labour.
Yeah.
It's all robotic and automated.
Yeah.
Labour actually represents a single-digit percentage in the cost of a finished product for us. So it's very small. Where our added cost goes to is all quality metrics, and by that I mean our bill of materials. So we use a higher quality bill of materials to make a higher quality product, and then wrap around Australian QA, quality processes, manufacturing techniques around it to get a great finished product that just lasts longer.
And for that, for the small, cost you're paying, you are paying for that quality assurance. You're paying for extra years on your roof, which delivers you extra power, brings your per kilowatt generated cost way below something that fails early.
100%.
Adds value to your house if you're a domestic consumer, because this will happen in a few years. It won't be have you got solar. It'll be what sort of solar you got. Where are these panels? Where's the guarantee? And if you're selling a house and it's got a 25-year guarantee on the panels, that's going to increase the value. You will get that value way back in your real estate.
And that's a really good point. With our guarantee, it's a 25-year replacement warranty,
Right.
And it's an Australian guarantee. So we're an Australian entity right here in Australia, operating under Australian law with our warranties.
Yes.
So we stand behind it, and it's meaningful.
Yes, and also there's your panels. I don't know the numbers. You might know them, but have significantly less embodied carbon in them anyway, because it doesn't have the transportation from say China.
Well, I do know the numbers.
Yep.
So we've done the research. We're about 25% less carbon miles.
Yeah.
And that's because when we bring materials in, we get more density in the containers as opposed to finished modules. But the big thing is we're about 75% of the embedded carbon to make modules here in Australia, in this factory, than out of China. So rough numbers, 550 kilograms per megawatt hour to manufacture in China.
Yeah.
125 kilograms CO2 to manufacture right here.
Wow.
So massive difference.
Massive difference. Yes.
Now, if you think about, even if we were the same amount of carbon invested, it takes a poorly manufactured module with poor materials might last 7 to 10 years. Yeah. Our panel lasts 30 years, so you're just getting far greater benefit from it.
If you're going to put an investment on you, especially on your house, you're going to put an investment on your house. Don't put a cheap one on there, because it's not an investment. It's a cost. And what you're doing is putting an investment on there. It's going to last a long time and increase the value of your property.
Well, solar's a long-term investment. You don't get a return instantly on it, and you're only going to get a return if it's working and working properly. Yeah. So the old saying, I'm sure you've heard it, buy cheap, buy twice.
Yeah. And you haven't picked a site for your gigafactory yet?
No, not yet. So we're working with various state governments and federal government and ARENA to lock down a site, but we hope we're not too far away from that.
Awesome. Thank you very much for the tour, Glenn. It's been fascinating.
Thank you for your contribution to Australian manufacturing as well.
You're welcome. Thank you.